Anyway, Morpheus laws. Didn't it just connect? There we go. And it's recording. Okay, and I come here, open existing file. Okay. Let's do this. So I'll go back to attendance slide. So if you didn't do the attendance, don't worry. And if I forget, just like come to me after the class and tell me that you were in the class. So I graded your exam as you saw on Canvas, and these are the results which I'm not happy with. So some professors have their exams difficult, or they go with the faster pace when they're teaching the material, and they scale the test afterwards. So for my class, I just want you all to learn some chemistry, and instead of talking fast or like teaching so much materials and having difficult exams and then scaling the test afterwards, I try to just have an easy course and easy exams, and then I expect like really good results. But based on what we see, we have like 1/3 of the class that are like D's and F's, and they are likely to fail this class. And 1/3 for our class is a large number, and I don't want that to be the case. And I feel like maybe I've been too lenient, or like I was too easy and students just like stopped studying. I don't know what's happening here. And if you guys have any feedback that want to share with me, things that I can do to improve the quality of our class, I'll be happy. And I tried to implement some of you guys' suggestions. When you send me emails, I try to have the course not too difficult, not too easy to be boring to some of you. And I'm sure that some of you experiencing that and being bored in the class because I explain something over and over again. But then when I realize that most of the students in exam get it wrong, I feel like I need to go back to explain it. That's why we have tutoring, and we have I schedule tutoring myself too with the students. So just I also commented on Canvas for those of you who failed the test to reach out to me, so we have the conversation, and I make sure that you not only pass the class, also get a good grade. And in my teaching, I have kind of like this philosophy that anything when I was a student I wish I would have seen, I try to implement for my students. For instance, if we would mess up an exam, most probably we didn't have a chance to retake it. So I was thinking at the time it would have been really good opportunity to be provided that opportunity. So for that matter, because I want all of you to get good grades, and if you already failed the class, if you already are on 50%, it's really difficult for you to get an A. I mean, impossible at this point. But even like passing the class would be really difficult because you don't know the first 4 chapters. And for you to learn the rest of the chapters, you should know these materials. So what I'm saying is that I'm going to schedule makeup exam 2 and also makeup quiz 2. I realize, most of you, or some of you rather, didn't do well, and some of you didn't do it at all. And for homeworks, if you go to tutoring, you can easily make up for it. Even if you get like 10 out of 20, you can go to 2 tutoring sessions and make up for it. But for 40 points, you should go to 8 tutoring sessions, and you don't only have this class, you have other classes as well. So I don't do that for homeworks because it would be, I should just write makeups, it's not feasible for me. But for quiz 3, I believe, right, and exam 2, I'm going to have makeups. For exam 2 would be in person, and for quiz 3 would be online. But for both of them, I ask you to email me and tell me that a time that works for either of them if you want to take them. Okay, so for quiz 3, if you say that Monday 4 p.m., I open the quiz for 1 hour, that period of time. Does that make sense? And I don't do that, post it for the whole class, because it gets confusing to people. That what is this one? What is this makeup, you know? So what I do, I open that for you, you take it, I record your grade, substitute it with your quiz 3, and then delete that assignment. I mean, I send you your solutions, but I delete that so it won't be any confusion for students. And the same thing for, exam 2 would be in person. So you set up a time for me, and I try to, put a time that works for all of you that want to take it. And also, I have this philosophy in the class, as you know, and as I repeated several times. If I provide an opportunity to one student, I do it for all class, because if one student didn't do well and now they want to take advantage of this opportunity, what about the student that got B and now they want to get an A, And I consider the higher grade. So you're welcome to just take the test and see what happens. So you have the opportunity to increase your grade. But you should study. And I had this difficulty last semester with my one-on-one class too. Students would come take, make up an exam. And sometimes I would write like 3 different versions of the same test, and then they would take it. Each time they would score lower and lower, or the same, or like 1 or 2 points more. So if you want to succeed in this class, you should study. And if you want that happen, I make sure that you understand the materials well, okay? So if you don't know anything about this class and you want to succeed, come to me. I schedule tutoring sessions with you myself, whether through Zoom or in person, and I make sure that we learn things well. But you should study. So you cannot cheat. You saw, I had like 6 different versions of the test, and I posted the solutions on Canvas last night for you to have and study all of them for your final. And so that is not an option. And also, if I caught you cheating, you'll get 0 on that test. And why should you do that, right? Any question about exam 2 and quiz 3 or anything else in the class? Any concerns you have? And feel free if you, yes?
So this has just been my experience so far, but I really like the homework because it's a good study tool for me. But I feel like I do worse on the homework. But by the time the test comes, I feel like I'm more confident in the test. I do better on the test because of it. But the homework combined is worth so many points that it seems like it's more weighted than the test. Because the amount of homework points that we've done so far equals the 2 tests we've done. And so since that homework is kind of like a practice for me, I don't do as well on it. And I feel like that is hurting my grade. Just because it's worth so many points.
Okay. So just to repeat what your friend said for people at home, I feel like most people can hear it, even like because we have like a smaller class. But basically homeworks have like homeworks and quizzes overall. Quizzes have like 500 points, and your exams overall have 500 points. And the thing about homeworks and quizzes is that they are open book, open note. So I feel like if you feel you're not doing so well on homeworks and quizzes, I encourage you to answer questions, right? And after you're done answering them, and I feel like the timing is decent for homeworks and quizzes, right? We don't have lots of numerical problems, so I feel like the time is good. But I'm welcoming any ideas. If you think more time would be beneficial, just let me know. But I think it's most of the time people finish homeworks and quizzes, or like homeworks specifically, in 20, 30 minutes. So I think that's not an issue. I encourage you to answer the questions. After you did that, before submitting it, go to the slides, go to your book, check the answers, and if you cannot find the answer, just Google the answer. I don't want to promote that, but these are open book, open notes, open resources. So you have any tool. You can just search for something, some concept, and you see like billions of videos on YouTube you can watch, right? Or sometimes the exact same questions are listed on the internet. So what I'm saying is that check your answers before submitting your homework and quiz to make sure that you got most of the problems right. And as I said, if you look at each homework individually, For instance, if you score 15 out of 20 for one homework, just go to tutoring session, and then it would, it's basically 20 out of 20, right? So that's why I'm promoting tutoring too, and I'm trying my best. And I had like several meetings or like go to tutoring session each week, for Sean to be prepared, mentoring you or like tutoring you. And I had like meetings with Dale, I told him my concerns, tried to have all the tutors prepared for this class, and also my other course. I had like I was talking to Samantha about SI Pass tutoring. I'm trying to bet my best to have these sessions really useful for you. And if you have any concerns, just tell me that I communicate with Dale, with Sean, but I'm trying my best for them. I share them my course materials, so they'll be up to date. So I feel like that's fair. So if you go to tutoring, I think you can easily make up for these, and because these are like, open book, open notes. But exams, I feel like you should have like exams, because sometimes the students, because these are open book, open resources, they do well, but they don't learn the materials for the method that I promoted, just like looking up the answers, they don't learn. So yeah, did that answer your question, Lena?
I will say, looking up stuff in your class is not easy.
Really?
Yeah.
No.
It's super hard to Google stuff for your class.
Oh, okay.
Like, if we were gonna have to, like, for example, if we had to cheat on that, and for example, right, we would fail. So
Okay.
it's really hard to Google stuff.
Huh, okay. I mean, so I try to have...
Way to be original, I guess.
Okay.
Yeah.
Yeah, thank you for the feedback. But I feel like, if you look at your book and slides, you have most of the information.
Yeah.
Maybe you miss like 1 or 2 questions, maybe. So I try to have like, I as of right now, I try to have like all the information on these slides, but I try to do a better job having all the resources you need also. Maybe I have like a screenshots of your book on the slides too, so it would be easier for you to look up the information. But thanks for the feedback.
Yeah, is it necessary to time the homework? Because I use the whole time and I still don't feel like I have enough to really dig into specific concepts that I might be struggling with.
So I encourage you all to first study the materials and then do the homework. So if you want to look at the homework as a study session, yes, it's like not enough time because you want to study. So that's why I encourage you to first study the lectures, make sure you know the materials well, and then look at the homework as a quiz or like test to see if you learned the materials or not. And after you answer the questions, just go back to your notes and make sure you answered them well. Does that make sense? Kind of? Okay, any other questions? And thank you all for the feedback. I really appreciate it. In my one-on-one class, I ask a question, everyone stares at me, if they do, and they're not on their phone or watching a movie or reading a novel. And then I'm like, does this make sense? And everyone looks at me, and I'm like, sometimes I feel like I'm speaking another language. I'm like, am I speaking Farsi? What's happening here? Okay. So I appreciate the feedback, because I'm here for you, and yes?
So in my opinion, I think like you're doing perfectly fine. I don't think we necessarily don't have the resources to get a good grade on the class. For example, the people that are getting A and B's on the test are the people that are going to tutoring, utilizing all the information and resources that you're giving us. Like I personally believe that you're going out of your way for us to get a good grade. And personally, I feel the people that are failing these tests and quizzes are the people that aren't utilizing like tutoring or like the videos you send out. So this is just my opinion, but I think the people that are failing are the people that are slacking and not utilizing the resources that you're providing us.
Okay.
But like in my opinion, I think you're doing perfectly fine.
Thank you.
I don't think you're, like, necessarily doing
I always, welcome good opinions too. Thank you. I appreciate it. Yeah. So sometimes I know, some students are struggling because, maybe they have like more courses or they didn't learn the materials on 101 well, and now they're struggling in this class too. So we have like all sorts of students in the class. And then some students have like medical conditions or like, so what I'm saying is that I understand if you're struggling for whatever reason, but I'm here to help. But you should want to study for me to help you. So there's no other way. Okay, and thank you for the nice comment. Any other comments, questions? Complimenting me. Okay. So now that I gave the talk about like the exam and all that, I'm going to bring to your attention 2 mistakes that I made in the exam. to 2 or 3 of the versions of the test that I wrote. And it's really interesting to me because the 2 questions, and this is one question and the other is in the one next slide. So these questions are just took from your book, word by word. And then when I wrote them, I messed it up. So it's kind of like interesting to me because it was just like the book in front of me, but I wrote it wrong. And that happens sometimes in your exams too, right? You know the answer, you just put the wrong, read the wrong number from calculator or whatever. So I'm going to explain this question because we didn't specifically talk about this example. So what is the product of the reaction of 1 mole of 1,3-cyclohexadiene with 1 mole of bromine molecule? I solved the question as it is. So first of all, remember that when you have like the chemical reaction, right, these coefficients here in a balanced chemical reaction tells you the moles, right? Do you remember from like other chemistry courses? And when you want to write, I write it here, 1,3-cyclohexadiene. First of all, E tells you that you have an alkene, right? So you have a double bond. This di here means 2. It means that you have 2 double bonds. Hexa means 6, right? 6 carbons. And then cyclo means you have a ring. And this 1 and 3 denotes the location of double bonds, right? So if you want to draw this structure, we have like 6 carbons in the ring, and then I have like 1, 2, 3, 4, 5, 6. You name them however you want. And you have 2 double bonds on carbons number 1 and 3. So the way that you do that, this is 1, right? The first carbon that you encounter. And the second one would be 3. It's a straight line, double bond. So this would be 1 and 3 cyclohexadiene. Any question about drawing this structure? And when I draw that at home, or like at my office rather, I had like this shape. You see that these 2 structures are the same. So it doesn't matter where you start counting them. Okay, plus, so this is 1 mole plus 1 mole of bromine molecule. It means that we have only 2 atoms. In the example in the class that we solved before, it was 2 moles of bromine. So you would convert these 2 double bonds, both of them, to single bonds because you wanted to attach 4 other atoms, bromine, Br, 4 Brs, and balance of carbon is 4, and this is the way to do it. But here we have only 1 mole of Br. So what we do is that we convert one of these double bonds to single bonds because we're attaching just 2 Br atoms. So how we do it is that I write the same structure here, and then I convert, for instance, this one to single bond, right? So this one I convert to single bond, and I attach Brs here. Okay? And 1, 2, 3, 4, 5, 6. So what is the name of this compound? Exactly. So this is 3,4 dibromocyclohexene. So instead of hexadiene, now you have hexene. So it would be like 3 and 4. Okay, dibromocyclohexene. Any questions? So I messed up these numbers here, right? But still, if you just look at these, the rest of the names, you could choose the answer theoretically or like ask me, But I deleted this question because it had error in it, and it was my bad. We're good with that? Okay. Now, and this was in another version of the test, version 5, but the same question. So I think you got it right now. And the other question here was, which of the following IUPAC names is not correct? And this is, again, my bad. I wrote it, I just saw one of them was like 4-methyl 3-pentene, I guess, So what it was like exactly in your book, and I wrote it wrong. But when you draw both of these structures, for instance, 2-methyl 2-pentene, so what you do, you have like 5 carbons, and then carbon number 2, you have like the double bond attached, and carbon number 2, you have methyl attached, right? And then you call this 2-methyl 2-pentene. There's nothing wrong with this, right? And then the same one, the other one, 4-methyl 2-pentene. Again, you have like 4 carbons, and then carbon number 2, you have the double bond. Carbon number 4, you have the methyl. And again, the name is correct. Nothing wrong with it. So probably, I should have gave you whether the structure and then say which one is the name, or I should have had another option that was actually wrong, or say both are correct, both are incorrect. So again, this question, both answers were right and both correct. It was my error. Okay. So for those of you who had these questions, I just, eliminated those questions, and then I graded out of 23 questions. So each question had like 4.378, basically. And if you got one answer wrong in the original version with 25 questions, you get 96. If you had like one wrong in this version that I eliminated 2 questions, you would get like 95.65. So it didn't affect any grades, I think. So if you see like, your grade like 95.65, it has like 2 digits that after decimal, it is what it is. Basically, I eliminated 2 questions. Any questions about these 2 questions? Clear? Okay, and now I realized, and some students came to my office hours and I explained the cis and trans isomers, and I didn't specifically say that in the class. I explained those, but not the following that I'm going to say. So I decided to also include some questions of that. So in one version, you saw this question. In the other version, you saw this question. So when you want to see which molecule forms cis and trans isomer, do the following. First, draw the structure. Let's start with 4-octene. How many carbons do you have in the main chain? 8, right? 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And where should I put the, let me do this. This one or this one. The double bond should be a green one or red one. It should be red one, right? Because the green one is 3, whichever being counted first. So for that matter, I eliminate this one. And then, rather here. And I have so this would be 4-octene. And let me put number of hydrogens here. How many here? 3. Exactly. So remember, when we had cis and trans isomers, we had like carbon-carbon double bond, and then for instance, if we had like Cl, right here. So this was trans, right? This general structure, and this one was cis, right? When you had like your 2 substituents at one side of the double bond, it would be cis. If they are on 2 different sides of the double bond, here and here, it would be trans, right? And this is as an example. Can you all see that? So now, in order, if you just look at this structure, maybe it's difficult to know if it has cis and trans. So just convert this form of a structure to this form. And how you do that is the following. You have the carbon-carbon double bond here, right? So it bonds to a carbon and the rest of the molecule and a hydrogen, right? So I can write here the hydrogen and here the rest of the molecule, which would be C3H7, right? Can anyone tell me the name of this? propyl, right? Is an alkane that lost a hydrogen. And what about here? This carbon is bonded to one hydrogen and the rest of the molecule, which is C3H7. So this structure, can it have cis and trans isomer?
Yes.
Right? So this would be cis, what I wrote here, and this one, C3H7, C3H7, hydrogen, hydrogen. This would be trans, right? Are we good with writing this now? So now let me also talk about 2-methyl-2-butene. Let me 2-methyl-2-butene. So first, let's draw this. So how many carbons I have in main chain? 4, right? Butene. 1, 2, 3, 4. And the double bond is on the second carbon here, right? And I don't put it before because that would be 1 butene. And then the same carbon has like methyl attached to it, right? So now let me draw the same in the same way that I did before. Now do it now. So first let me put the hydrogens. How many here? And then how many here? 0, right? Because you have 1, 2, 3, 4. How many here?
1.
How many here? Okay. Now this carbon-carbon double bond, this carbon attaches to one carbon and 3 basically methyl CH3 and a hydrogen, right? What about this one?
CH3 and CH3.
Yes. So this structure, can it have cis and trans? No, right? Because even if I switch this, for instance, if I switch these two or like these two, I get, the same structure. So even if I put the hydrogen, for instance, here, these are the same structures. I just rotate them. Can everyone see that? So that's why these are not cis and trans. Any questions about this cis and trans in alkenes? Good. Okay. So with those, I'm going to stop talking about the exam. But anyone has any further questions about the exam? And also feel free to reach out to me, email me if you have more questions. So now I'm going to continue talking about aromatic compounds. So what are aromatic compounds? What do I mean when I say aromatic compounds? Exactly, they have a benzene ring, which is like, you have like 6 carbons, right? And you have like double bonds that they alternate, okay? And as I told you, I'm going to give you these structures in exam and then ask you questions when I talk about naming compounds, because, I don't want you to just like, although this is like organic chemistry and you should remember a bunch of stuff, but I don't know, I feel like it's just best for me to give you this, and as long as you know how to use them, you'll be fine. But when you solve, examples, you kind of remember that, okay, if I have OH, that is phenol, right? If I have CH3, it is toluene. Or like if I have NH2, it is aniline. So you learn this as you solve examples. But for these ones, for instance, bromobenzene, I expect you to know, because when we have like Br as substituent, we call that bromo, right? Or like chlorobenzene. And nitrobenzene, also remember that when you have like NO2 attached to your benzene ring, we call that nitrobenzene. So it's not N, it's NO2, okay? And ethyl, you should know what is ethyl, so that's why you should also remember this. And propylbenzene, you should know how to write propyl. Any questions so far? Straightforward. For today. And also we talked about ortho, meta, para, and I asked you those in the exam too. And just remember the name. So if you have like your group here, one of them, and the other one, the opposite side, it would be para, kind of like, you can remember as parallel, right? These guys are kind of parallel. However you want to remember, I'm just like trying to give you hints or like kind of like for you to memorize this. Or for instance, for ortho, I was telling myself, okay, we have this group here, the other one is here, so they are close, like ortho, close. I don't know, whatever works for you, as long as you know that is ortho. And also the other one, there's one other possibility, right? That is meta. That you have like one, double bond and one single bond in between. Any questions? This PowerPoint, ortho, when you have like the para. So also one thing that I talked about 2 sessions ago about naming when we talked about ortho, meta, para, we said that, do you remember when we were talking about naming alkenes? I told you when we start from here, we should necessarily cross the double bond, right? So if I have a substituent here, Cl, what is the name of this compound?
3-chloro.
Exactly. Pentene. Oh, hexane, right? I have like 1, 2, 3, 4, 5, 6. 3-chloro. Chlorohexane. Okay, so we don't say 1, 2, 3, 4, 5. We don't say 5-chlorohexane. I told you that we should cross the double bond. But when we have like the benzene rings, even if you put Br the other side, we call that 1 and 2 dibromobenzene. And that is because, as we talked about before, and we talked about calculate included in this, but you remember that we said these double bonds as if they alternate, so these compounds are really stable, benzene ring is really stable, and we even said the reactions are substitution, they are similar to alkanes, remember? So that is because of that. So when we name the benzene ring, even if you have like Br this side, we just say 1 and 2 dibromobenzene. Or it is like ortho structure. Any questions? Is that clear? Yes.
So you don't have to cross
No.
double bond first in this case?
Yes.
Because it spins or something?
Exactly.
Okay.
We kind of treat them as they are single bonds in the sense of naming. We just want to reach the substituent first. Or just remember that when you have it would be 1 and meta, it would be 1 and 3, when it would be 1 and 4. Does that make sense? Any questions?
So we don't necessarily have to put ortho, meta, or para.
It depends on the question. So we mostly use, for benzene rings and aromatic compounds, we mostly use ortho, meta, para. I wrote 1 and 4 again here, para. But if you use the numbers, that is correct too. You should know both. Great question. Any other questions? An structure didn't. Okay. And here is another example. For instance, we say ortho dichlorobenzene, or like meta dichlorobenzene, or like para dichlorobenzene. Okay. We go here. When you use ortho, meta, para, you don't use the numbers anymore.
Oh.
Because it just implies that where they are. Does that make sense?
Yep.
Benzene, I think. So now, here, I want to ask you guys to name these compounds. Any volunteer?
Do these just go alphabetical order? Is that how you-
Yes, if you have like both of them, Br and Cl, yes. So first of all, if your substituents are even different, they don't necessarily they don't have to be both Cl to use ortho, para, meta. They can be different substituents. You still use those. Yes, answering the question.
Tentative guess.
Okay, sure.
Ortho 1 bromo 2 chlorobenzene.
So when you use, so
Would it be ortho, bromo, chloro, benzene?
exactly, bromo, chloro, benzene. So what about the next one?
Quick question.
Yes.
Does it matter which one you say first? Could
It's
it be
alphabetical.
ortho or-
Alphabetical.
Alphabetical.
Yes. And yeah, it's better to have the structures. And this is how you see the question in exam. I give you the whole table that had like the different benzene rings. So you know how, so for this one, Br and Cl, you already knew, bromo, chloro. But for this one, for instance, I give you the table so you can look. Can anyone guess the second one?
I had a question.
Yes?
Is it only ever two substituents for these rings? Or can there be more than two substituents?
It can be more than two
And are they
substituents.
named the same way that way?
So, great question. I feel like if you have like I didn't see a specific example, but I bring some examples next session. Great question. But I feel like, if you have like, for instance, aniline and phenol at the same time, you include both in the name. That is my guess. But I make sure that that's the case. I'll bring some examples.
Would the second one be meta methyl nitro benzene?
What is it again?
Would it be?
So what do you have here?
That's a methyl group.
So this is a methyl group, but we also call, when we have methyl group, we call this toluene,
Oh.
right?
So would it be nitro toluene benzene?
So what is the position of them?
Oh, would it be meta
Uh-huh.
toluene benzene?
Here, automatically it changes your
Oh, I see,
benzene
I see.
to toluene. So here we call this nitrobenzene because it was a nitro added to benzene. So if you have this NO2 added here, that would be, or here, I mean here for instance, right? That changes your toluene to nitrotoluene. Does that make
So
sense?
it's just meta nitro toluene.
What about this one?
Styrene.
Exactly. So here, remember that if you have only benzene, that would be, for instance, like this example. You say nitrobenzene or like chlorobenzene. But when you have some of these substituents, now you're not dealing with benzene in the naming per se. So you have like a styrene, right? Now, chloro is added to styrene, right? So, and then you should also name the position, right? So they are like para. What about next one? So you have like a benzene ring, and now you have like OH attached to it. So what is this? Exactly. So here you have like phenyl till here, and a chloro is added to it. And what is the position of these two? Okay, added this for no reason. Okay, what about this one? So what is a benzene ring that has NH2 attached to it? Aniline, right? And now, what is this? C2H5. Ethyl, right? Uh-huh.
Ethyl and ortho.
Uh-huh. Okay. Yeah. So here in the solution that I posted, I also said that, note alphabetical order. And you can also, instead of ortho writing the whole thing, you can just write O. Okay. So I guess this is like faster for me. So what about the next one? Or maybe, so let me go back to here. So what we call this, so when you have like nitro group here, and then, so when you have CH3, this converts your benzene to toluene.
So do you not have to state the methyl group?
So the methyl group is basically toluene.
Oh.
When you have like this CH, exactly. Any questions here? So we call that para-chlorostyrene. Does that make sense? Questions? So let me
Yeah,
metal, right? So here, if they are like next to each other, we call it ortho. If they are like, on two other sides, we call it kind of like here, para. So if they are like one double bond and one single bond between them, we call that meta, right? Chlorophenol. Exactly. Ortho ethyl aniline. Are we good with naming these? Does that make sense? Okay, good. So now, here I give you in the exam, draw the structure of ortho-dinitrobenzene. So how do you do that?
Would you just attach another nitro group to the number 2?
Exactly.
Either side, I guess. On either side, right? Or
Yes, you can do either side as long as you're like close to this,
Right.
that would be the same. So one of these, whether this one or this one.
Yeah.
Because you have two nitro. Does that make sense? And I just delete this one to not be confusing. But if you attach the other side, that would be correct as well. What about, meta M nitrotoluene? So toluene is here, right?
So it'd be on 3, and it would have N2O.
Uh-huh.
Or
NO2.
NO2, yeah.
Exactly. So here, this is toluene, and then meta would be like one double bond, one single bond between them, and then you attach NO2. Any questions so far? Does this make sense to everyone? Okay, so now this is one thing that I asked you to remember for the other substituents, and the names, phenyl, toluene, I'm going to give you. But for this one, I just asked you to remember that if you have two methyl groups, you call this compound xylene. So if you have like one methyl, you call that toluene. If you have two, you call that xylene. Okay? And depending on, where you attach them, you have ortho, meta, para, right? And then if you want to name this compound, you have like an ethyl group attached to a benzene. So you call that ethyl benzene. Okay? Any questions? And these are like terminology that chemists came up with. So if you have two methyl groups, they will call them xylene. And I give you like these structures, in the exam, and sometimes I have like, only one bond, one double bond here, or like two. So pay attention, you should have a benzene ring. You should have double bonds that they alternate, okay? In order to have like an aromatic compound. Oh. So now, so this is kind of like basically what we said before, that although we usually use like, meta, ortho, para in naming aromatic compounds, you can also use the naming system, right? Numbering system, sorry. So here, for instance, how do you name this compound?
Can you do numbers, but if you were going to use the names, not the numbers, could you do ortho and para since there's one on ortho and para? Or you just use the numbers?
So. Let's see.
Does that make sense?
Yeah,
And
yeah.
How would that work on like the last one there? Would it be ortho? Because there's two options. I'm just kind of curious.
Well,
about
in
that.
this case, it'd just be easiest to use the numbers.
Yes, I think in this case it's easier to use the numbers, but I'll double check to see if we can use also, like, yeah. For instance, say, meta di chloro. So I think, for instance, here, yeah, I should double check on that. Don't want to say something that, then I can correct myself. So I'll check on this and then tell you next class. But in general, here, if you want to name this compound, if we call 1, 2, 4, we have trimethyl groups attached to benzene. So this is how we name this. Yes?
Why isn't it toluene? Because you got the methyl at one place, why wouldn't it be a toluene?
So if you have only another substituent attached to a toluene, you can name methyl ortho para and then name the compound toluene. But in this way, because we have two more substituents as well as the methyl, as well as so we have two more methyls as well as toluene, I think it's just easier to use numbering. Does that make sense? Okay. And let me see what I wanted to say. Okay, so here, for instance, if you draw 1 and 2 dichlorobenzene, that would be metachlorophenol. Okay, and phenol, and also the same thing. Oh, sorry, I messed this up. So, if you have ortho dichlorobenzene, that is the same as 1 and 2 dichlorobenzene, and if you have metachlorophenol, that is also 3-chlorophenol. And I had more examples in the next slides with them, and also bring more examples for you. So I'm also going to continue